Welcome back for flip video 2.9. In this last flip video, we're going to discuss the gravity model and how the gravity model is used to predict migration patterns. So just to start us off, the gravity model is a formula. It's a formula that reads population of city 1 times population of city 2 divided by the distance between them. Using the title of the model itself, the gravity model is essentially going to be used just like gravity is a force that the Earth exerts upon all objects. We're looking for the amount of the force. We're measuring the force between two different places. And if two different places have very large populations, there's likely to be a very strong pull between them. If if two different places are very close to one another, so in this instance our denominator would be quite small, then we'd have a very strong pull between these two different groups. Now, of course, what this really looks at here, just back us up for a second. The gravity model then is predicting the movement of people and goods between two places. Now, this makes sense in context. It makes sense that Arlington, Virginia, and Washington, D.C., separated by 3 miles. Arlington has a population of about 225,000 people. In Washington, D.C., let me check my numbers. I'm going to go to my analysis questions. 658,000, right? If these two places, population of city 1 times population of city 2 divided by 3, well, they're going to have a pretty strong gravitational pull. There's going to be lots of migration and daily circulation between Arlington and Washington, D.C. Now, let's make it broader, right? Let's look at, if you consider New York City and L.A., right? There's a large distance between them, about 3,000 miles in between those two places. Yet they're still going to have a fairly large gravitational pull. There's still going to be a large movement of people that pull between New York and LA. The gravity model would argue because there's lots of people. When there's lots of people, you're going to have a lot of greater diversity of people. People are going to continue to go back and forth between places, or going to continue to go to places, where they're going to find people like them. So the greater the population, the greater the attraction. So let's say that someone was trying to move internationally. Well, they're more likely to move to a place with lots of people. They're looking for people who eat similar food as them, who have similar religious practices, who generally have a similar culture. They're looking for places that have lots of economic opportunities. Those places tend to be places with a very large population. So large populations tend to ensure that there's a large gravitational pull between those two groups. So as it says here, the greater the population, the greater the attraction to the place. That means that because there's more goods and there's more people in those areas. What determines that gravitational pull, what makes that pull greater between populations of large cities, the cities with large populations? As I said, the greater the diversity of the people, the greater diversity of economic opportunities. It's kind of like a multiplier effect. The more the people come, the more opportunities there are, and the more opportunities will continue to be presented by the incoming immigrants. This is related to distance decay, right? So I'm going to go back here for a second. What it proves is that larger cities will have strong connections between them. There'll be more migration between them because spatial interactions here are directly related to populations. The more that people interact, right? And it's inversely related to the distance between them. So the more people, the more spatial interactions, right? So New York and Shanghai are going to have significant pull because they're very large populations of City 1 and City 2. But it's inversely related to the distance between them. The distance between New York and Shanghai would mean that they would have fewer interactions than New York and Camden, New Jersey, which are directly next to each other. Yet, New York and Shanghai both have enormous populations. So the gravity model tells us there's still likely to be interactions and migrations between those two different groups. And this kind of just helps us see what I mean by that. City 1 and City 2 are going to have a very strong bond because City 1 and City 2 both have large populations. The size of the circle indicates the population. City 1 and City 3, even though City 3 has a smaller population, it's located closer to one another. So the gravity model shows us that denominator would be much smaller, so that they too would have a strong pull. City 2 and City 3 are both more distant from one another and have smaller populations. So they're not necessarily going to have a strong bond in the way that City 1 and City 2 and City 1 and City 3 have. So this really shows us sort of that pull. The force of the pull is going to depend upon the size of the population and the distance between the objects. Now, just to highlight this denominator piece, we see that the larger the population of the cities, the greater the pull. The inverse relationship, though, is the distance between them. And this relates to distance decay. So the farther away the place is, the less likely someone is to migrate there. That's that's what we call the friction of distance. Distance decay says the farther you get from the node, the less it influences you. Friction of distance really refers to the concept that the absolute distance, so not relative distance, but that literally the number of miles or the number of kilometers kilometers between two places is going to affect the distance between them. The closer they are together, so meaning a denominator that's very low, greater the interactions. Whereas if there's a very large denominator, that will lessen the interactions between those two people. And that relates to gravity, the concept of gravity, just right. Well, let me not confuse ourselves here. Let's just keep it that as it is. The distance decay here, farther the way is less like there is to migrate. So that really where we see that concept of friction of distance. The farther it is, the less it influence, the less there will actually be interactions. Now, why isn't this necessarily true? It's not the size of the population isn't necessarily the only thing that's going to dictate whether someone is likely to migrate to a place. It certainly does help us explain this, though, because again, the more people, the more interaction, the more opportunities, the greater the diversity that are available, the greater the amenities that are available in a given place. But that doesn't always necessarily apply. That doesn't necessarily encompass the ideas of selectivity. We talked about those ideas of who's most likely to migrate at certain times. Well, that's going to influence where they go, right? Where a person with a family migrates is going to be different than where a young adult with no marital ties or children is going to go. That also just doesn't account for the fact that sometimes people just move. And sometimes maybe someone wants to move to India just because they want to check it out. Maybe someone wants to move to a new city just because they want to try a new way of life, right? That human factors and who's most likely to migrate doesn't necessarily always mean who migrates. And just because where people are likely to go doesn't necessarily mean that's where they will go. So this is not, the gravity model is certainly not perfect. And moreover, transportation technology. Now you can get that's a picture of the global flight patterns. Global flight patterns means that you can be anywhere in the world in a matter of hours, right? It could be 24 hours, but you could be anywhere in a matter of hours. And that means that people might move farther. The distance might not matter to them to us as it once did. For example, it may no longer be the friction of distance, this concept of how much absolute distance influences us. Well, maybe having texting or things like the WhatsApp, so you can talk to people internationally just by texting, right? That might mean that someone's actually more likely to move all the way down to Sydney, Australia, as opposed to moving to Philadelphia from Washington, D.C. So there are increasing transportation technology is starting to make the gravity model less relevant, since distance isn't necessarily dictating decisions in a way that it once did. All right, that's it. The gravity model. Here are your actually, did I get everything here? Yeah, I did. Okay. There are your analysis questions. According to the gravity model, which cities would have more migration between them? So you're going to have to do a little bit of math here, my friends. Welcome to use a calculator because you're working on millions. And based on your response to number 1, why would there be such a strong pull between those places? And lastly, how would a business use the gravity model? How would the gravity model apply to economic relations? That's it.